Hello and welcome back to another video of math destruction. Oop, I don't know what that was. Let's just move on. Composition. This is a new thing. We've not done it in this class before, so make sure you understand what it means. And basically that open dot, if you go all the way through all the equals to the far right, it just means there's some what are called nested parentheses where we have a function inside another function like that. And order of operations says start inside, do all that, and then move outside, do all that. So that's an important concept. So you probably aren't going to see the expression on the far right. You're probably going to see fog. And hopefully you know where fog comes from. So you have to know what that open dot new symbol means and not confuse it with, you've never seen this symbol before. It is not add, subtract, multiply, or divide. So it's something new. All right. So we have these two functions and we are composing them, compositing them. I don't know the word. Anyways, so the G function is on the right of the symbol. It's going to go into the F function. So sometimes writing with the nested version, if that helps you visualize, good thing, do it. So we're taking the G function and we're replacing the X in the F function. And then one of the concerns sometimes is how far do you go? Where do you stop? So it's a good idea to just do simple things. 3 squared, 9. 2 times 9, 18, like that. So there is a small amount of, but not negligible, points for the completely simplified. So be careful, like that. Domain. So a new kind of rule for domain. We are never going to look at the F or outside function. It could be, you see from my examples, I do it forward, reverse. So it's always the outside or the one on the left. That doesn't matter when we're determining domain. You look at the inside and then you follow it all the way down to the final answer and compare those two. So the G was inside and it said you can't use 0. And then everything down to the bottom says you can't use 0. So we can't use 0. 0 causes us to divide by 0. So it is out. Okay, let's reverse that order. So now F is on the inside and G is on the outside. So G said, don't use 0. Well, now we can use 0. It doesn't matter. We see what happens. Let's see what happens. So put the F into the G, which basically just puts the F in the denominator, and we have a completely new divide by 0 expression. So denominator not equal to 0, solve. It's a quadratic. If you stick with factor in every single quadratic, that's okay. But you can see how I solved it here. If you solve it this way, remember the plus or minus at the end. Quadratics always have 2 answers. Ba-dum-bum. And then exactly like all the other divide bys, that combo of symbols is how you put it together. All right, one more. We got a root and a square that are going together. So the root is on the inside. Whatever the domain restriction from the inside goes all the way to the end, no matter what. Let's see what happens. So we put that inside. The root is inside a square. They cancel, distribute, combine. We get 4x. 4x is a diagonal line. It's a polynomial, but the restriction from the square root is still there, even though the root canceled. So you have to go back to that even root and use it to help with the domain. Boop, like that. Awesome. Now the notes may or may not have another example. I decided it was too complicated. So I would suggest it's too complicated.